Hey there, my name's Gary Sims and this is Gary Explains. And I hope you had a chance to look at my review of the Raspberry Pi Zero 2W. It's a single board computer with a quad-core 64-bit processor, access to the GPIO pins, Wi-Fi, Bluetooth and so much more. Now, one thing we know is that at its heart, the processor that's in this tiny little board is the same that's the one in the Raspberry Pi 3. Now, the Raspberry Pi 3 processor can be clocked at 1.2 gigahertz and can be overclocked sometimes to 1.3 or even 1.4 gigahertz. Now, the one in this board is clocked at 1 gigahertz. Now, the question is, can you overclock it to match or even beat the performance of the Raspberry Pi 3? Well, the answer is yes, you can. So if you want to find out more, please let me explain. Okay, so any computer system, when it is running instructions, there is a pipeline. It has to fetch the instructions from the memory, it has to decode them, has to actually execute them, there has to be interactions with things that are going on with the main memory, getting data, writing data back, and all these things happen in a clockwork fashion. And I use that word specifically because every time the clock frequency goes up or down, the next stage of the logic occurs. And that basically means that the quicker the clock speed, the faster it is, the quicker those instructions can be executed and the quicker your programs run. Now, the Raspberry Pi Zero 2W runs at 1 gigahertz. Now, the Raspberry Pi 3 runs at 1.2 gigahertz. Now, the reason there is a difference between the Raspberry Pi 3 and the Raspberry Pi Zero 2 is because of the thermals. Now, there are a couple of things that control how much heat is produced by any particular chip. One is the process node that it's made on. 7 nanometers, 5 nanometers, 14 nanometers, 28 nanometers, all those numbers you may have heard about. I've got lots of videos about them here on this channel. Another big factor is the frequency. The higher the frequency, the more energy is used and therefore more heat is produced. And also the voltage that's supplied to the processor. In fact, the voltage squared is actually one of the numbers used in the formulas for calculating energy and heat. That actually directly affects the amount of heat that's produced. Now, obviously, when a processor gets too hot, it can't function properly, there are missteps in the logic, it can overheat and so on. So all of these processors need to be cooled. Now, of course, the thing about the Raspberry Pis, most of them is that you don't have any kind of cooling on them at all. There are no fans here. There's not even a heat sink on these things. So this has been designed in such a way that the copper inside of the board is actually used to disperse some of the heat. So when it's running at its 1 gigahertz default setting, the heat is acceptable. It can be dispersed by the design of just this little board being air cooled passively. There is actually a temperature sensor inside the processor of every Raspberry Pi, and that can be monitored so we can see what kind of heat is being produced by the processor. Now, I'm going to leave a link in the description below to a write-up about some of the things you need to know to get all this stuff working, how to monitor the temperature and so on, so you don't have to kind of type in, you can cut and paste and so on. So just look for that in the description below. But basically, when you run the Raspberry Pi 2.0W and you max out those 4 cores, that quad-core processor to 100%, and you run it for like 5, 10, 15 minutes, it gets to around 73 degrees centigrade. Now, when it gets to 80 degrees centigrade, there are some things that kick in, some safety measures that kick in that drop down the frequency because obviously the processor is getting too hot. So in any overclocking thing we want to do, we want to keep it under 80 degrees. Now, to overclock a Raspberry Pi, you need to edit a file called config.txt, which you'll find in the /boot directory. So you need to edit /boot/config.txt. And it's a fairly simple text file, and there are some values that you put in there where you can determine the different frequencies and voltages that you want applied to the board. Again, I'll leave the exact details in that link in the description below. Now, you can set in there the different frequencies. Now, if you set a frequency of 1.1 gigahertz and you up the voltage by just a fraction to help that go along, then you can get the Raspberry Pi Zero 2W to work without any kind of active cooling, but you will need to stick a heatsink on it. So the one that I have running here now in my setup, I have it running now all day long. It's clocked at 1.1 gigahertz. It's got a little heatsink on top of it, a passive one, and it gets quite warm when you touch it, but it's able to cope with that situation. Now, if you want to go higher than 1.1 gigahertz, then now you're going to need some active cooling. Now, as I said, one of the factors is making sure that the chip stays below 80 degrees. Another factor is that you can just crank up the clock speed too high, or you can get the voltage wrong, and basically the system becomes unstable. And during your testing of trying to overclock one of these devices, you are going to make sure that you need to cut the temperature down and that it's stable. Now, when I say stable, I mean stable over a long period, not just during the boot up. I've had situations where I was testing different voltage levels and different frequency levels, and after 15 minutes of full load, 100% load, only then did suddenly everything froze. Not because it overheated, but because it wasn't quite stable enough to run at that particular frequency. So of course, having tried 1.1 gigahertz with passive cooling, I then moved on to try to go higher with active cooling. There are a whole variety of different fans and things that you can buy for Raspberry Pis. I took a fan shim that is one of the ones that you can buy for Raspberry Pi 3 and Raspberry Pi 4. I kind of stuck it on the Raspberry Pi Zero. I've got a header on my Raspberry Pi Zero. That worked okay. There are probably better ones that are designed for this, but as long as you've got some active cooling, it does really work. And in fact, it works really well because running that same setup with a fan running now, it lowered the temperature from up there at, nearly 80 degrees right down to 40, 45 degrees Celsius. And those are asking the room temperature here where I live in the world, and now at this time of year, it's about 21, 22 degrees here in my house. So it's obviously running hotter than room temperature, but notice how it came down so much from near 80 degrees right down to the middle of half of the temperature. So active cooling really makes a big difference. Now, once you've got active cooling going, you can now crank up that voltage, you can crank up that frequency. And as I said, remember, the voltage increase is voltage squared when it comes to energy consumption. So any tiny increase in voltage does actually have a big impact on the amount of heat that is produced. Now, I was able to crank up the frequency and to 1.2 gigahertz and to 1.3 gigahertz, and then I even went to 1.4 gigahertz. Now, at 1.4 gigahertz, it became unstable no matter what I did. Different voltage levels, different cooling was definitely active. It booted and it ran, but after about 15 minutes, it would freeze. Sometimes after 10 minutes, it would freeze. So I lowered mine down now to 1.3 gigahertz, and that seemed to be working. Now let's just quickly talk about voltage. In that configuration file, there is a setting you can use called over voltage, and that allows you to increase the voltage ever so slightly to the processor. Now, normally the Raspberry Pi Zero 2W runs at 1.2 volts. And using that over voltage setting, every time you increase it by 1, so if you have over voltage equal to 1, it goes up by 0.025 of a volt. And so then you can go to overvolt 2, overvolt 3, and it goes up each time. Now, to get this 1.3 gigahertz running, I was using an overvolt of 6. Now, of course, that is quite a big difference from the standard voltage. Again, that contributes to the heat increase. Now, what you have to do is you have to try to play between the frequency and the voltage. You want the voltage to be as low as possible, it makes it stable, and you want the frequency to be as high as possible and to be stable. As I said, in my final setup, I had 1.3 gigahertz with an overvolt of 6, and that ran pretty well with active cooling. If you want passive cooling, drop it down to overvolt of 2 with a clock frequency of 1.1 gigahertz. As I said, I'll leave notes in my GitHub repository, and there'll be a link to that in the description below. So what's the bottom line? The bottom line is here is that for $15, 14 euros, 14 pounds, whatever it is you end up paying for one of these devices, you can actually increase the performance by 30 or 40% in real terms by increasing that clock frequency. So for example, I have my thread test tool program. Again, that is in my GitHub repository. And if I was using it to run a particular search for some prime numbers, multi-threaded, it was taking 17.2 seconds on a default Raspberry Pi 202W. And then when I cranked up that clock speed to 1.3 gigahertz and I increased that over voltage, that was dropping down to 12.4 seconds. So from 17 seconds to 12 seconds, that's a real term gain of actual performance. So overclocking definitely has its benefits because things will run faster. Now, obviously things that are dependent on I/O, for example, to the SD card over the internet, they will not run faster because once the packet's out on the internet, nothing you can do about it. But stuff that is CPU intensive, and that would include include running the desktop and so on, they will benefit. You will see a benefit by running the clock speed at a higher rate. Okay, that's it. My name's Gary Sims. This is Gary Explains. I really hope you enjoyed this video. If you did, please do give it a thumbs up. Don't forget you can follow me on Twitter at Gary Explains, and I also have a newsletter. Go over to garyexplains.com, type in your email address. You won't get any spam, but you will get the newsletter, and I hope you enjoy it. Okay, that's it. I'll see you in the next one.